query number 6. Okay. You have 3 different functions there, okay? F, G, and H are twice differentiable. Twice differentiable is the line, the curve or the graph of these 3 are smooth, okay? So when x is 2, g of 2 equals h of 2, right? So g of x graph and the graph of h of x, they have an intersection at point 2, right?
Yeah.
So y coordinate is 4. Okay, the line y equals 4 plus 2 over 3, x minus 2. So 4 plus, this is line take out. Y equals 4 plus 2 over 3, x minus 2. That means what? This is y minus 4 equals 2 over 3, x minus 2, right? This line passes through the what? 4 and 2, okay? Pass through the 4 and 2, and its slope is 2 over 3. That's the meaning, okay? Are you okay with this?
Yeah.
In this line, g of x, h of x, they have the same point of view, okay? All right. So when x equal to, they have tangent pose to this line. Oh, it's very interesting. Tangent, but this is not tangent line, okay? Okay, they looks like this one. I think they look like some of this in case of this one, okay? They have tangent over here, what is that? They have, right, tangent line, okay? The same tangent line, okay? Maybe something kind of this graph. Okay. All right, we got the all information there, okay? X is 2 and the graph of h at x equal 2, right? Okay, this is the graph of x equal 2, not like this one, okay?
Yeah.
The first question is a h prime 2. Okay, what is the value of h prime 2? The derivative at x equal 2 on the h. One of this was g of x, the other one is h of x. Right? So f prime 2 is what? The slope of this line tangent, right? It's okay? It's the same point. It's going to be equals 2/3. Okay? Oh, this is very easy one. 2/3 is the answer, okay? Because this is derivative at x equal 2, right? That is the slope of tangent at this point. Second one there. A is the function given by ax. They create a new function over here. Ax is what? 3x cubed and h of x. Write the expression a primes x. Okay? We have 2 equations, right? One is a prime x derivative of this one. Second one is what? The derivative at x equal 2. We're going to evaluate these numbers. The first one, the derivative of ax equals to, we have 2 functions there, okay? One over here. The first one, second one, right? So we have to use the product rule, okay? The first prime, 3x cubed prime is what? 9x squared, right? And times second prime. So the one is what? Don't touch first one. 3x cubed. Second one is a h prime x derivative, okay? This is a product rule. That's the answer, okay? We can leave it this way, okay? That's the answer. After that, we put this number x is 2. So 9 times 2 squared is 4. 9 times 4 is 36. And h over 2 plus, and 2 cubed is 8. 3 times 8 is what? 24. Are you okay with this? Probably here, right? Okay, step by step. 9 times 2 squared is 4 and h over 2 and plus 3 times 2 cubed is 8. Okay, 2 cubed is 8 and h prime 2. That equals 36 h over 2 plus 24 h prime 2, right? H over 2 is how much? When h over 2, what is the value of y? Over here, right? H over 2, that is 4. Are you okay with this?
Yeah.
They said over here, g over 2 equals h of 2 equals 4 here, okay? When x is 2, y is 4 here, okay? This is 4 there. 36 times 4. After that, 24 times h prime 2 is still 2/3, right? The slope of this line tangent, okay?
Yeah.
Times 2/3. Now simplify. 144 plus 16. Okay? What is that? 160, right? 160 is the answer. Number 1 and 2 is okay, right? I think A and B, you can do that, right? Definitely, all right?
Yeah.
Okay, now try the next two. Function f h, the function h is satisfied. Yeah. Now function f h of x defined this way. X squared over 4 over 1 minus f of x cubed. Yeah, x cannot be 2, right? Okay,
Yeah.
that is 0. Okay, it is known that the limit of h of x can be evaluated using L'Hopital's rule, okay? So you're going to use x close to 2. So x squared minus 4 over 1 minus f of x cubed.
Yeah.
We use L'Hopital's rule, okay? Because what? When you use L'Hopital's rule, always what? When you put this number 2 there, x squared minus 4 is 2 squared minus 4 is 0, right?
Yeah.
To apply L'Hopital's law, the denominator also 0, isn't it? If not, we cannot use L'Hopital's rule, right?
Yeah.
Are you okay with this? Denominator should be 0, then if this is true, then we can apply, okay? L'Hopital's rule, right?
Yeah.
Okay. So over here, this is 0, it's okay. A denominator should be 0, right? So we have one condition there. 1 minus f of x cubed must be equal to 0. So what is it? F of x equals 1, right? Are you okay with this? 1 cube is 1, right? So f of x cubed equals to 1. Okay? So f of x is what is it? Third root 1 still 1. You can use this one, okay? Anyway, 1 minus 1 equals 0, okay? All right? We don't need this way, right? Okay. Okay, now limit the h of x when x close to find the f of 2. Okay, so when you put this number 2 there, it's gonna be 0, okay? So the number 0, f of 2 equals to 1 over here, right? We already got this number, okay? It's okay? All right. When you put this number 2 there, I'm gonna use the 2 over this one. Directly this one. When you put this number 2 over there, 0 and 0, put this there, so the number is 0, okay? So from here, f of 2 equals 1, okay? That's fine. Ready?
Yeah.
The next one over here, show the work. So what is f of prime 2? F of prime 2 is how much is that? F prime 2.
Yeah.
Right?
That'd be prime 2 is
Find
1.
f prime 2. This is f prime 2, right? Take a look over here. Can you see it over here? Limit. This one is actually what is that? When x close to f of x squared minus 4 over 1 minus x cubed. Let me see. Just give me. I confused. I confused.
Yeah.
How can we find f prime? F prime 2 is okay, but f of 2 is okay. We're gonna find f prime 2, right?
Yeah.
The derivative, right, on f of x at x equal 2, right? Okay, we're gonna find the slope of tangent at x equal 2 on this graph of f of x. Okay, we take, right, L'Hopital's rule there, okay? Anyway, that's right? Okay,
Yeah.
that's fine. Because when you take a L'Hopital's rule, we get the f prime 2 there, okay? So, oh, this is a little hard to understand. Limit x close 2, now we got this one. 1 minus f of x. I'm going to cube over here, okay? And x squared minus 4. Take L'Hopital's rule. L'Hopital's rule is 1 minus f of x cube and the square, right?
Yeah.
Okay. After that, numerator, denominator, the derivative of numerator, okay? X squared minus 4 derivative is 2x times denominator, okay? 1 minus f of x cube. That's it. And minus, don't touch numerator, okay? X minus 4, and we multiply to what? Denominator, right? It's okay? Derivative of denominator. Derivative denominator, what is that? 3 move to the front. I'm going to 3 move to the front. After that, f square x. And right, this is chain rule, okay? After that, you multiply f prime x, okay? That is, put this number 2 there now, limit value.
Yeah.
2 times 2 is 4. Inside is what? The f over 2 cube, right? I'm with this one. Cube. Minus x is 2 is what? 2 square minus 4 is how much? 0. It's okay?
Yeah.
Yeah, this is 0, right? All the way 0. Over 1 minus f over 2 and cube and square, okay? There is a limit value there. Just give it, let me figure out. H of x, oh boy, we cannot do this, okay? This is h of x, okay? Sorry about that. H of x is this one. This one, okay? We need carefully understand the question, okay? It's okay? But limit when x close 2. So limit x close to h of x. That is equals to a limit x close to x squared minus 4 over 1 minus f of x cube. Is okay?
Yeah.
But when x is close to over there, this is the limit value how much? 4 over here. Can you see it over here? 4.
Yeah.
H over 2, right? That is continuous. Okay? Continuous over here. When it's close to y close to 4, right? That is limit value, okay? This limit value is 4. Oh my god, this is a little, okay, hard to understand, okay? But that's fine anyway, okay? If you understand this, h of x is given by the limit already over here, 4 over here, okay? But then, now we can find the value of f prime too, okay? So actually, so oops, there is no f prime h prime 2 there, we delete. There must be f prime 2. Let me check. Oh, I did mistake. I'm sorry. We use right L'Hopital's rule, right? That's can use L'Hopital's rule, okay? Not this way. Because we go too fast, right? Without understand the questions. Okay, from here, right? L'Hopital's rule, okay? So limit cross 2. Take a derivative, right? We need to take a derivative. Then you can use what L'Hopital's rule, okay? Denominator derivative is 2x. Numerator the 1 minus 3 times f of x square, right? 3 minus 2 is square n times f prime x, okay? Yeah, that's it. Now put this number 2 there. 4 over 1 minus 3, f of 2 squared, right? F of 2 squared. And f prime 2, that is the limit value, okay? But we know that f over 2 we already got over here, okay? F over 2 is 1 over there. Are you okay with this?
Mm-hmm.
This one equals to what? 4 over 1 minus, this is 1 squared is still 1 times 3 is 3 f prime 2. Are you okay? It's a little hard, okay? This one equals to 4 over there, okay? From here we can find f prime 2 there. If this is 4, this is 4, this is 1, right? So 3 minus 3 f prime 2 should be equal to 1. Are you okay with this?
Yeah.
Oh, boy. We take integral derivative of here. 1 is a constant 0, okay? We did a lot mistake today. Sorry about that. Okay, this is 0. The next one is what? 2x and the minus 3, okay? So put this number 2 there. Now 4 over minus 3 over 2 n square, okay, 1 by 1, f prime 2, okay? That is equals to what? 4. It's okay? Yeah, that is equals to 4. The limit value by h when x approaches 2, okay? Now, the bottom is should be equals to 1, right? So negative 3, f over 2 is 1 there. So f negative 3 times f prime 2 equals to 1, right? Because 4 over 1, that is 4, right? The bottom numerator should be equals to 1, okay? So from here we can find now f over 2 equals how much? 1 over negative 3, okay? So we can write that negative 1 over 3, okay? That's the answer. This one, okay, you have to read carefully, right, what the question is, okay? All right. But this case, I just want to try, okay? Only AB is enough, okay? I think, okay? AB is enough, right? Because most of the students, they are a little hard to, it's very hard, right, to figure out the C, I think, okay? Okay, this is why it is known G of x is H of x, okay? H of x is what? Always higher than G of x, okay, on this interval, 1, 2, 3, okay? K is the function satisfied what? Another between these two for x and 3, okay? K is continuous at x equal 2. Try this one, okay? So it looks like this one. H of x is greater than G of x in this way. Like this is roughly we can say, okay? H of x, this is G of x, already higher than this one. Find this 1 and 3 over here. That's another function k. K is in the middle over here, okay? K is lower this one and higher the other one. It's okay? So kx, we set up the kx greater equals to G of x, but less than equals H of x. But question over here, k is continuous at x equal to, at x equal to k is continuous. We said what? Kx is continuous at x equal to. That's the questions.
Yeah.
Okay, g over 2, first one, we're going to find the derivative, right? Okay. G over 2, can you show me a g over 2 over here, h over 2, right?
Yeah.
Okay, that differentiable, right? That's continuous and differentiable because the slope of tangent is 2/3 over there, okay?
Mm.
All right? Okay. Anyway, g of x and h of x is for given over here, okay? H over 2, I'm going to do h over 2, h of x. That's one. You can use the h over 2, it doesn't matter, okay? Okay, I'm going to graph of this. I'm going to h of x is continuous.
Yeah.
Okay, this is a continuous. So between these two continuous 2 and 2, right, at x equal 2 there, okay? So actually this looks like they are equal, right? At x equal 2, they are equal, looks like this one.
Mm.
The other one is also what looks like here to here, right? At this point, was still this is tangent line, the same line, okay? So kx is between these 2 points. It should pass through this point, okay?
Yeah.
That's right.
Mm.
Because over here limit g of x, x close to, okay, or you can use, right, this theorem. Kx greater than equals to g of x, but less than h of x. Okay, when you take a limit over there, okay, limit x close to g of x, limit x close to h of x, limit x close to h of x. But this limit is 4, we got the 4 over here, right? Can you do that?
Mm.
That's 4 over here, right? That is limit value. So between these two, also the limit also is 4, right?
Mm.
Between these 2 points, 4 and 4, 4. This we said squeeze here, okay? I think they are asking about this squeeze here. Is okay? So k over 2 must be equals to 4, right?
Yeah.
So that is continuous, okay? Because we have a k equals 2 is 4, right?
Mm.
It's okay? Yeah, that's the way we can answer this one. This one is a little hard to, a little weird questions, okay?
Yeah.
All right. That's it. That is 2019, okay? We're gonna have a little more about without using calculator section, okay?
Yeah.
Okay, I'm gonna put this one out. This one, yeah, let me see. This one is work. 2019, number 6. And we're gonna try 2000, today 18, okay? 18 questions. I'm gonna put it 2018. 2018, no, here. Okay, we don't have 2018. Just give me a minute. We have 2018, no, this is not. Please let's find. Okay, here, what, 2018. This is 2018, right? This is out. Okay. So we're gonna try this one first. Okay.
Mm-hmm.
All right, number 3, the graph of continuous. This is 2018, okay? This is 2018 free response, okay? Number 3. Graph of continuous function g, the derivative of function f is shown above. The graph of g is a piecewise linear functions, okay? Up to 6, another one is what? Graph, okay? Quadratic graph there. The equation is given, okay? 2 minus x minus 4 squared. The first one, try number 1 there. F of 1 equals 3. This is original, right? G, this is the graph of G, not F, okay?
Yeah.
So, and also what is the graph of what? F of negative 5.
Mm-hmm.
We're gonna find this one. Okay? So derivative of f of function f, so what is that? F prime x is what gx. Is okay?
Yeah.
Yeah, g of x is what? Derivative of f of x. Or f of x is what? Antiderivative of g of x. This is, we said, fundamental theorem of calculus. F of 1, this is later. This is before, right? Negative 5, okay? So later is what is it? F of 1 equals how much? F of from negative 5 plus the change, right? Everything in y, negative 5 to up to the 1, okay? F of prime x. That is g of x, okay?
Yeah.
Equal this one, f prime, this we're gonna find this number. This one is 3, right? 3 equals f of negative 5 plus negative 5 to the 1. F prime x is a graph of gx given by the graph.
Mm.
That's it. So we're going to find this graph of, okay? The integral of negative 5 to the 1 g of x dx. Okay? Integral is what? The area under the curve, right?
Yeah.
From negative 5 to only 1, okay? Negative 5 to only 1. So we have a negative 5 over here. Graph is this way. Here 1 up to 1 over here, okay? That's it. What is the separate? So this was the rectangle, right, from negative 2, okay? This is the length is 3. This length is 3 also, right?
Yeah.
So the area of this one is 3 times 3 is what? 9, but it's under the right x-axis, okay? That is negative 9. This area is negative 9. What is the other area? This also under x-axis, okay? Right.
Yeah.
That is what? 1 times 3. This is 1. This is the height is 3. 1 times 3 divided by 2 is what? 1.5 is the still negative area, okay?
Mm.
But there's no area of this one, okay? Now from the 1 over here, this is 1, height is 2. So this is also what? 2 times 1, okay? And divided by 2 equals what? 1. It's okay?
Yeah.
This area is a positive one. Positive one. What is the total area? What is the total area? Negative 9, this is negative 9 plus, minus, negative 1.5, and plus 1.
Yeah.
Okay, negative 10.5 plus 1, negative 9.5, okay? So 3 equals, so f of 5, how much? You use this one. 3 equals f of negative 5 plus 9.5, okay? Negative 9.5, that's the equations. From here we can find f of 5, right? F of negative 5 equals what? Plus 9.5 plus 9.5. 12.5, okay? That's this.
Yeah.
So f of negative 5 equals square 0.5 inches, okay?
Mm.
Are you okay with this? This is 2018, right? We are doing 2018. Okay, let me check the answer in case, okay? Just give me a minute. We are doing number 3. Yeah, 25/2. That's correct. Okay. Our second one is we're gonna evaluate 1 to 6 g of x dx. 1 to 6, where is it? The graph over here. 1 is up here, that is 2. We start from this point. 1 to 6 over here, 2 down. Okay, after that, you're gonna make right quadratic, okay? This up
Yeah.
to 6. Okay. This one is 3, and this one is 4, and this is 5 there, okay? We're gonna find the area of this one, 1, 2, and this one, and this one, and this one. That's the area, right? Under the curve, okay? Not above the curve. From the graph, you can, this is easy one, okay? That's the rectangle, okay? The length of this is 3 minus 1 is 2. The height is 2. Area of this one, how much? Above the right x-axis, okay? 2 times 2 is 4 is positive, okay? Now let's find under this one. The equation is given, okay? This equation is given. What is that? Under the equation over here, I'm going to use the equations. This equation is g of x equals 2 x minus 4 n squared, okay? Now let's find this one. 1 to 6 over here, we're going to find, okay? 3 to 6, okay? 1, 2, 3, we already got, okay? We already got 1, 2, 3, we already got.
Okay.
Plus 3 to 6, we have to use this derivative, okay? All right. The first one is 1 to 3, we already got, that is the area is 4, right? So we're gonna find this one. 3 to 6, take this one inside there, 2 times x minus 4 squared, okay? What is the antiderivative of this one? You can take this one as it is, same thing, okay? Because inside the variable is 1. Just take this one as x, same thing, okay? Plus 1 there is 3, okay? You can divide by this. So 2 over 3 x minus 4 cube. It's okay? That is the antiderivative, okay? The same thing. 2x squared antiderivative is how much? Plus 1 divided by 3, right? So 2 over 3 x cubed. But x plus minus a is also same thing, okay? So that is the antiderivative. We take integral from 3 to 6. Or you can 2 over 3 move to the front, it doesn't matter, okay? It's same thing. Constant always can move to the front. So that is 2/3 inside how much? 6 minus 4 square, right? 6 minus 4 is 2 square is 8. And the minus, second one is how much? 3, move, put this number 3 in there, okay? 3 minus 4, that is x minus 4, right? Okay. 3 there, negative 1 squared, still negative 1, right? So this equals to 2 over 3, 8 minus 1 is 9, which is equal to 6. Okay, this one area is 6. What is total area? 4 plus 6. Okay, total area, this is 4 and 6. So 1 to 6 g of x dx equals to 4 plus 6 equals to 10. Okay. That's the answer, number B. Also, number A and B is okay, right? You can do that using the formula of the area, okay? All right, number C. For this interval, negative 5 up to 6, from here to here, right? From here to here, okay? So x equals negative 5 and 6 only, okay? Open interval, right? Not include the endpoint. If any is the graph of f both increasing and concave down, we check it out. Increasing concave down is what? It's slope, right? We check out the first derivative. Okay? Are you okay with this?
Mhm.
Okay.
Yeah.
So f prime, you want to check, right? F is what? Increasing on this interval, right? Increasing. And another way, concave up. You have to show this one. So f derivative is g of x. It's okay. We check out f of x. This one we check out f prime x. This one is what? Second prime x. F prime x is g of x. F second prime is g prime x. It's the same thing, right? Because what? Derivative of x is what? To find the g of x. Okay? Now take graph to g of x. On this graph is given already. G of x between negative 5 and 6. Negative 5 over here, 6 over here. I'm going to graph one more time. Okay? Here, 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 here. Okay, on this one, negative 5 up to 6. They are all increasing. How do you think?
Yes.
How of this one?
Actually,
Okay.
no. No, it's not increasing.
So negative 5 up to 6. Okay. On what open interval? We're gonna find the interval over here, increasing concave up, right? Over here, increasing. It's okay,
Yeah.
right? These two sides, this is the minus is what? Decreasing. Okay, because this is f prime x. Is it okay?
Yeah.
Okay. But we check out only this one. Increasing section, okay? From here, which graph has what? Concave up. Concave up is the slope of this one is the concave up, right? Second
Yeah.
prime, isn't it? Slope of this one is the f of second prime, okay? This is a slope is what? Second prime is what? 0. This is what? This side is the f prime x equals positive. This one is the concave down, right? Second prime x is what? Slope of this line is a negative number, concave down. After this point, they're all what? Concave up, right?
Yeah.
Okay? So which interval over here? Where is it? Concave up, increasing only these portions. From here to here, right? That is increasing, belongs to over here. Increasing and its slope is positive, concave up, right?
Yeah.
So we take it this one. Where is it? 0 and 1 over here, right? That is 0 and 1.
I guess.
So if x equals from 0 to 1, the graph of f is what? Both increasing and concave up. Okay. Another one over here too, from here to here, right? Okay. Increasing slope is what? Concave up. Okay. So from this point, 4 and what? 4 to x is just 6. Okay. On these two intervals, the graph of f of x is what? Increasing concave up, right? That's okay. Over here, they are increasing both. And together concave up, okay, on this interval. That is number C, okay. Number C, I think it's okay. You can do there, okay. All right. Now we continue on number D, okay.
Okay.
Find the x-coordinate of each point of inflections. We're gonna find the x-coordinate of each point of inflection of a graph of f. Okay, this is about f prime, right? Not graph of f, okay? F prime. Given the region of here. Okay, I'm gonna make, okay. I cannot write, okay. Here and here. Here and here and down over here and quadratic. This is actually what is that? F prime x, okay, which is equals to g of x. So we're gonna check, right? They are concavity, right? Concave up and down, okay. At that point, there is what point of intersection, okay. Slope of this one is f prime x equals 0, nothing. It's okay. All right. Slope over here, what is that? Positive, right?
Yeah.
Okay, slope this one positive. That is a concave up. But right up this one is what? 0 again. It's okay? They are not changed, right? Concavity, right? Because concavity is what? Plus minus, not plus 0. It's okay?
Yeah.
All right. So this is not point of inflection point. Okay? So we are doing to find inflection, right? Okay. This is nothing. Still nothing over here. This is positive 0, nothing. It's okay? But over here, right there. This slope of this one is this is second derivative, right? Less than 0 is a concave down, right? It's okay?
Yeah.
Slope of this one, this is first prime. Slope of this first prime is the second prime. That is a concave down. Right at this point, that is a concave, slope of this is a concave positive, right? Concave up. So at this point is what now? Point of inflection, okay? So where is the x coordinate at this point of inflection? X equals 4, right? This is 4. This is only one point of inflection point, okay? At this point. It is okay, right? Maybe we can find we can try, okay, to draw an original graph of f of x, okay? Okay, now let's make this is x. We start from here. That is decreasing, right? Slope is a constant. Okay, that is the slope is a constant up to here. Decrease. Okay. The next one is still minus and decreasing, but this is a concave up decreasing, right? Concave up decreasing. It's okay. But slope is 0 is what? Nothing over here. Okay. Slope is 0, isn't it? So graph looks like this one. This was straight line, and this one this way, and this one. That is not complex. This is not concavity, okay? That line. After this, that is increasing. The slope is positive, but concave up, right? Concave up increasing. This is concave up increasing.
Yeah. It is.
After that, the slope is 0 again, right? This is not inflection point, okay? Inflection point, they are changing concavity this way, right? This is 0, okay?
Yeah.
Not concavity. Right, this one is concave down, still increase, okay? Concave down, increase. Are you okay this?
Mm-hmm.
Increase, right? This is graph of this one decrease, but this is positive, right? Concave up, concave down, increasing, okay?
Yeah.
This way, concave down, increasing. After this is phobia. After that, still increasing over here, right? But concave up, increasing, that is what? Concave up, increasing. This point is they change concave there, concave down, concave up. Only this point is what inflection point, not this one, not this one, okay?
Mm-hmm.
So over here. Here, and if they have a right straight, that is not concave. This point is not what? Point of inflection, okay? Only change right there, concave over here, concave down, concave up. This point is what point of inflection, not straight line, okay? Are you okay with this?
Yeah.
Or sometimes this way. Straight line, okay? That is not concave over here. So choice D is, well, X is 4 only, right? That only one point of inflection point. Okay. That is number 3. Okay, now move on number 4 there. All right, you have a table 2, 3, 5, 7, 10, and 1.5, 2, 6, 11, 15. That is the value of y, okay? The value of x is times t. Height of tree at time t is given by twice differentiable function h. And the ht is measured in meters and t is measured in years. Okay? So select the value of ht is given by the table over here. So I can make right a little graph over here, okay? This is 2, 3, this is 5, and this is 7, and this is 10 over here. 8, 9, 10. Ah, okay. 7, 8, 9, 10. When t is 2, this is t. When t is 2, height is 1.5. 1.5. 3, that is height is 2. Sorry, height is 2. 3 is height is 2. 5 is 6. 5 is 6 over here. 7 is 11. Approximate, okay? We don't have enough time. And the 10 is 50. Up here, 50. Okay? That's the point. All right, use the data in table to estimate h prime 6. H prime 6, where is 6 is over there, right?
Yeah.
But there's no data over here. So our definition is what? F prime is the slope of this line. Okay? So approximate 6 in the middle of it, right? We defined, okay, f prime 6 in the middle of this point, okay?
Yeah.
H prime 6. So is equal to a slope of between these 2 points defined by h prime 6. Okay, what is the slope of this one? 11 minus 6, y2 minus y1 over x2 is 7 minus x2 is x1 is 5. Okay, the slope of this secant is called what? Defined by h prime 6 in the middle point. Okay, this is 5, this is 2, equals to what? 2.5. Okay,
Yeah.
so the slope of tangent line at this point 6 is what? 2.5. It's okay?
Yeah.
Right. That is our definition, right?
Mm-hmm.
B there. Explain why there must be at least a 1 times c between 2 and 10. H prime is 2. Okay, H prime is what? Instant slope, right? Instant slope. It's okay? Because they are differentiable, that's not continuous, okay? with continuous, right? Differential means what? Including continuous or smooth line. That is mean value theorem. When you have this one, always what? Mean value theorem. Okay. Take a look mean value theorem from here to here. Okay, between 2 and 10, right? So 15. Check it out the slope of this one. Okay. 15 minus 1.5 over 10 minus 2. It's okay.
Yeah.
Between 2 and 10, that's correct? Yeah, between 2 and 10, a slope is 2, okay? But this is not slope is 2. We're going to check, right? We choose some other point over here, okay? This one you actually take a look. When you have it, 13.58, that is not equals to, right? So we choose some interval again, okay?
Yeah.
But they said the f, oh, no. Why there must at least one time t between 2 and 10. 2 and 10, they said. Oh. This one a little. We're gonna choose, okay, some other interval, okay. But they said this one is between and 10. Okay, any interval is okay, right? So which interval has a slope of 2? We choose this one, okay? Slope of 2. Okay. Oh, this one is slope of 2. First one is 7 and 3 is what? The difference. 7 and 3 difference is 4. And 11 minus 6 is 5. That is not 2, okay? No, 7 over 2 is 9. No. So the 6 minus 2 is 4. Okay, 3, 5, okay? When you over here, 3 and 5. X is what? 3 and 5. This is T. This is H is what? When X2, H is 3, H is 2, when X T is 5, X is 6.
Yeah.
We choose these 2 points, okay? This point, okay? We choose, now check out that their slope is 2, okay? 6 minus 2. X2, H2 minus X1 over 5 minus 3. So 4 over 2. Yeah, that is equals 2, right? Yeah. So this point C must be what? Between 3 and 5. Is okay? Yeah, that is what guaranteed. There is a point of C, okay? We have our 3 and 5 over here. This is a 6, this is 2. We have a graph over here, okay? Smooth line. But this slope is equals to 2. So there is another point over here, right? Which is a parallel, right? This C is what? Between 3 and 5. Are you okay with this?
Yeah.
Okay, so we have to explain this way. Is it okay? So first, you have to show that this interval and find what the slope of this one, because this is a differentiable, right? The graph is a differentiable. That's why by the what? Mean value theorem, okay? We can apply that the mean value theorem. There is just C between 3 and 5, okay? Between C, but C must be what is it? 3 and 5, okay? So this one, you can explain this, okay? By mean value, you have to say this one, okay? Mean value theorem, okay? If you don't say mean value theorem, okay, no credit, okay? You have to say by mean value theorem. Okay, the condition is also you have to give, right? This is exactly right, equals 2, okay? You trapezoid sum with 4 intervals, subintervals indicated by their in table approximate the average height of a tree over the time 2 and 10, right? Average height, average value, okay? Yeah, this is we said not average rate, average value of HD. Average value of HT is what is it? Between 2 and 10, right? So it's 10 minus 2 difference. Minus 2 and 10 under the all area, right? Okay, H of T. Now this is definition of average value of T, okay? Now we're gonna find, okay, all this area, right, under this height. Using what? Trapezoidal approximation, okay? So you can make trapezoid here, one trapezoidal, two trapezoidal. I'm going to delete this one. This is 3 trapezoid. This is another 4 trapezoid. Now let's find this trapezoid. This is the base, upper base, this is the bottom base, lower base, and this is the height is 1, okay? The first one is how much? 2 plus 1.5. Okay, 2 plus 1 and times height and divided by 2, right? So 3.1.5. 1 plus 1.5, 3.5 divided by 2, 1.75, okay? The first one is 1.75, first trapezoid. Second trapezoid. Upper base is 2, bottom base is what? 6, okay? 2 plus 6 times, at this time the height is 2, times 2 and divided by 2, okay? That equals 8, is okay?
Yeah.
The third one over here, this is the second one, this is the first one. Third one, I'm going to use this third one over here. Upper base is 6, bottom base is 11, okay? So 6 plus 11 and times height is 2 still and divided by 2, that is 17, right? The last one over here. Upper base is 1, bottom lower base is what? 15, okay? So this number 4 is what? 11 plus 15 and times height is 3, okay? And divided by 2. That is 26 times 3, right? 26 divided by 2 is 13 times 3, that is 39. Okay? That's the all area of this or trapezoid. So we're gonna add this one. How much? Use this one. You can add this one. 8 plus 17 is 25. 39 times 25 is what? 64. Plus 1.7. 65.75. Okay? 65.75. This will equals what? 1 over 8 times 65.75. That is the average. You can divide it by 8, right? Because this is the area of this one. You're gonna make a flat over here, okay? Flat. This is height is average value, okay? You can divide it by this is 8. It's okay?
Right.
So how much this one? This one you cannot use a calculator. So 65.75 over 8. 8, 64, 17, 2, 16, 15. 1 over here, 8, 70. 8 is what? 64, 60. 56 and 4, 5. I think you can leave it in the fractional, that is better, okay? 65.75 over 8. You can leave this in, okay, too.
Yeah.
Okay, or is that equals what? 8.21875. This is exact number, okay? That's not,
Yeah.
this is not approximate. This is okay too, this is okay too, okay? That is the average value, okay? That is the number C. So number A is okay, number B is okay. I think number C a little more work, but you can do that, okay? Try this all three questions, okay? So actually you don't, I think you don't need the last one. Last one is already a little, okay, weird and more work, okay? Anyway, you can try this one. The height of a tree in meters can be modeled by the function. Now they define the function g of x is what? 100 x over 1 This is another tree, okay? This is not this h of t, okay? This is a new one, right? The height of tree in meters can be also modeled by g. But this is hg. Okay, they use the same thing, but this is by the equation we use by g of x, okay? Yeah, that's fine. Where x is the diameter of the base of a tree. A little different way, okay? The x is a diameter. This is what the year is a time t years, okay? A little different, okay? This x is independent is what? Diameter of the base of a tree, okay? All right.
Yeah.
That is anyway new function, okay? When the tree is 50 meters tall, okay, when ht equals what? They use capital T. When ht equals 50 meters tall, okay? 50 meters tall. Diameter of base tree is increasing at this moment. At this situations, diameter base, okay? Diameter of the base is increasing. So diameter is d, it's okay? That is x, okay? So dx and dt, are you okay with this?
Yeah.
Diameter is a function of time, right? They're gonna change. Okay? Diameter of a tree is changing every year, right? So that is equals to 0.03 meters per year, okay? At this moment, right, the height of a tree is right at 50 feet, okay? 50 meters, I'm sorry. According to this model, what is the rate of change of the height? Rate of change of height, the dh dt, right? That's when you find dh dt. Are you okay with this?
Yeah.
With respect to time, okay? At time when the tree is 50 meters height, okay? Same as what? This at this moment, okay? At this moment. So we're gonna find the dh dt, okay? So how can you start this one? What is the rate of change, the height of a tree? This height of a tree is back time. The time when tree is 50 feet. At the time when tree is g of, this is a new one, okay? G of x, okay? This is g of x. When g of x equals to 50, okay? But this is h of x, okay? That's the same numbers. Anyway, we're gonna find over here, from here, dh and the dt, okay?
Yeah.
A little confused, right?
Yeah. That's fine.
Okay, at this times, we're gonna find, okay, the derivative over here, okay? What is the derivative of this one? dg dt, it's okay?
Yeah.
dg dt equals how much? With respect to time t there. The first derivative times denominator, right? Quotient rule. 100 times denominator 1 plus x. Minus, don't touch the numerator and take derivative of denominator 1, okay? Over 1 plus x squared. It's okay?
Yeah.
No. Because x is, we take a derivative with respect to t, not x. Oh, this is a little confused. Okay, over here, derivative of 100x different, okay? With respect to time t, not x, okay? So 100x is what is it? 100 times dx dt. Are you okay with this?
Yeah.
That is derivative of 100x. And times after that, we multiply 1 plus x, right? Second one, don't touch first one, new x. Now take a derivative of denominator. What is that? Denominator derivative is what? X prime is what? Dx dt, okay? Over 1 plus x n squared. Okay? This one is. Now we're gonna find to get the value of x there, okay? We're gonna find dx dt is given by the 0.03, okay? Dx dt, this one and this one, 0.03. This is a 0.03, but we still need the value of x. How can you find the value of x from here? Okay? At this moment, g of x equal 50. G of x equal 50 over here. Right? I'm gonna write down this one. At this moment of x. So 100x over 1 plus x equals to how much? 50, right? At this moment. At this time, you can find the value of x there, okay?
Yeah.
So from here, we can find 100x equals 50 plus 50x. Minus 50x both sides, 50x equals 50. When g is what? 50, x is what? 1, right? So we need this value of 1, not g value, okay? Now put this number 1 there. So dg dt equals, okay?
So,
Now let's find dg dt equals how much? 100 times 0.03 and plus 1 plus x is 1 is 2, right? I'm going to write down 2 there. 1 plus 1 is 2. And minus 100 times x is 1, that is 100, dx dt is still 0.03. And over 1 plus x is 1, right? 1 plus 1 is 2, square is 4, okay? Now check it out. A lot of work, this one. 100 times 413 is 3, okay? 2 0 is out. 3 times 2 is 6. This one is what? 3, right? 100 times 0.03 is 3, okay? Over 4 is 1. 3 over 4. That is dg dt. It's okay? 3 over 4. So dg dt. Okay, signified, or this number, right? This is the height, dg dt, okay? Not dh dt. That signified dg dt. Okay? So dg dt is over here, 3 over 4, right? So dg and dt equals 3 over 4, okay? But we have a totally different equation, okay? We don't need the h. We just only what? G of x defined this way. But this is a little more work, right?
yeah.
But this is still what? Linear rate. Linear rate problem. That is a number 4, okay? So how about this? Maybe you can try 1 and 2 definitely, right? Or you can try your trapezoidal approximation too, up to number C, okay? All right. Now D a little hard, but that the linear rate, just try this one too, okay? Number D. Number 5 there. Really read their questions very carefully, okay? f will be the function defined by f of x e to the x and cosine x. Okay. Find the average rate of change. That is the rate of, not the average value. Okay. Find the average rate of change is between 0 to pi, the slope of tangent, slope of what? The secant. Okay. So average rate of change is what? Slope. You can use the AROC. You can use what? Average rate, the AROC too. That is equals what is that? F of pi minus f of 0 between 2 points. Change in x is what? Pi minus 0. Are you okay with this?
Yeah.
So put this number pi there. E to the pi cosine pi and minus e to the 0 cosine 0. Okay. Over pi minus 0, just the pi. So e to the pi cosine pi is how much? Negative 1, right?
Yeah.
E to the 0 is 1, cosine 0 is 1, that is 1 over pi. So actually, negative e to the pi minus 1 over pi. Okay? That is the average rate of change. Is it okay?
Yeah.
Right. The slope is negative, right? This slope, 2 point, 0 and pi. The secant is a negative slope, okay? All right, number B there. What's the slope of the line tangent to the graph f x equals 3 over 2 pi when the point is x equals 3 pi over 2? Line of a tangent, we need a point, right? X is given over here. We're going to find the y coordinate too. Y coordinate x equals pi over 2. Put this number 3 there, okay? This is the value of y coordinate. So 3 pi e to the what? 3 pi over 2. And the cosine 3 pi over 2. Cosine 3 pi over 2 is 0, right? So this one times 0 always 0, okay? So the point is on the tangent line is what? 3 pi over 2 and 0. That's the point, okay? Now you got the point already. Now we need the slope. That's right. Slope is what? F prime x when x equals 3 over 2. You're gonna find this slope, okay? This is the slope. Slope of tangent. It's okay, right? Okay, now let's find the slope of tangent. Take a derivative, f prime x. F prime x is how much? Separate. E to the x derivative is still e to the x. Times cosine x. Plus, first one don't touch. Second one is derivative is negative sine x, okay? Cosine x derivative is negative sine x. That is f prime x. But we're going to find the slope of tangent, which is derivative at x equals 3 pi over 2. Put this number 3 pi over 2 there. E to the what? 3 pi over 2. Cosine 3 pi over 2. Still 0, right? So minus, okay, this one, e to the what? 3 pi over 2. And minus sine 3 pi over 2. Sine 270 degrees, which is 3 pi over 2, 270, negative 1. This number negative 1. This is 0, okay? So, times 0 over 0, negative 1 over 0. This is negative 1. Negative, negative, positive 1, right? So, this one is e to the what? 3 pi over 2 only. That's the slope. What the equation of line tangent? We got this point and slope already. So y minus y1, y minus y1 equals 0. Slope is y, e to the what? 3 pi over 2. And x minus 3 pi over 2, right? But we really write down just y equals y, e to the 3 pi over 2. And you can leave it this way too, minus 3 pi over 2, okay?
Oh.
You can leave it this way. But they're asking you to find the y, only slope, right? Okay, only slope this one. slope is e to the what? 3 pi over 2, okay? From here. The number C, find the absolute minimum value on interval 0 to pi, absolute minimum. When you find the absolute minimum, always you have to take right derivative, okay?
Yeah.
And you can compare, right, which one is the minimum at the end of 2 point and between 2 point there is what? The local minimum, okay? The first one, you can use this one, okay? If you start from here, this is going down, going up, right?
Yeah.
Here. Absolute minimum, absolute maximum. Now compare this point. This point is higher, this one, this is the absolute maximum. This point is lower, the other point, this is the absolute minimum, okay? That's why we need to find this number, okay? And after that, we can find, right, the value of y at the end of point. So compare which is the lowest one, okay?
Yeah.
F prime x we did already over here. This is F prime x. E to the x cosine x minus e to the x sine x, okay? So first prime we did already. To the x cosine x minus e to the x was sine x. Can you see that over here?
Yeah.
E to the x cosine x minus move to the front minus e to the x sine x, okay? That is derivative. So to make a zero over here, okay? To find the local maximum and minimum, okay? Relative maximum or minimum too. E to the x is common. E to the x cannot be zero, okay? So cosine x minus sine x equals 0. This one cannot be 0, so this one should be 0, okay? Cosine x, sine x, they are equal, what is that? Only what? X equals pi over 4, isn't it?
Yeah.
It's okay to make it cosine x equals sine x, that's a co-function, right? Cosine equals sine, sum of these two angles is 90 degrees, okay? X plus x is 90. 90 is pi over 2, right? So pi over 2 divided by 2 is what? X equals pi over 4. You can see that over here. So maybe you can use the graph over here. Cosine x graph pi over 4 this way. This is a cosine pi over 2. Sine x over here, right? So they are equal at this point, pi over 4. So at this point, cosine is higher sine x, okay? So for this point, pi over 4, f prime x is what? This one is positive, higher, minus this minus, lower, this higher, that is minus there, okay? At this point, that is what? Relative maximum, right? That is a relative maximum there. But that is a maximum, not minimum over here, okay? So maybe you can check out the end point. But that's not the answer, right? That's the highest point. So we're gonna find, okay, at x equals 0, at x equals pi over 2, right?
Yeah.
Okay, put this number. At x equals 0, how much this one? From there. E to the 0 times cosine 0. E to the 0 is 1, cosine 0, 1, that is 1, okay? So I accurate this one. And actually that is 1 there. F over 2 pi. Put this number e to the 2 pi and cosine 2 pi. Cosine 2 pi is what is 1, right? Still 1. That is e to the 2 pi, okay?
Yeah.
E to the 2 pi is what? That is 2 pi is like greater than 1. That is the highest over here, right? This is e to the 2 pi. The graph looks like this one, okay?
Yeah.
This is pi, okay? Relative maximum. So check out these 2 points. Where is the lowest point? This point is what lowest one. That is point is what? Absolute minimum.
Yeah.
It's okay? Let me check the answer. Just give me 1 minute, okay?
Okay.
Okay. I did mistake. The interval is what 0 to 2 pi, okay? Not 0 to pi over 2. Okay, cosine x sine x is equal, right? Okay.
Yeah.
This is a mistake. Not only 2 pi, okay? You extended the pi of 2 pi there. Okay, I'm gonna graph of this one. Just give me a minute. This is a little hard, okay? Sine is this one. F of this one. Sine is this one. 2 pi. Cosine is here. From here, 0 over here, okay? And down over here, here, and here, okay? Then the graph looks like this way. Very equal this point and this point. We have 2 points, okay? Between 2 pi there. Using the graph is easy one, okay? But this one is higher than cosine x is higher, right? So this is a positive. So when you have 2 points over here, you have 2 point pi over 4, and the other one is a pi, another pi over 4 is about 5 pi over 4, right? That is a little hard, okay? I understand, because we cannot use our calculator.
Yes.
So between this one is the positive, right? Because the height is cosine is higher. The next is sine is higher, that is negative. This is another positive, right? So when x equals pi over 2, that is the local maximum. Pi over 4 is the local minimum there, okay? The graph looks like this way. This graph over here, pi over 4. This is a pi over 4 over here. 5 pi over 4 down over here, okay? The graph is increasing over here, local maximum. But this is local minimum. And again, okay? But we're gonna find, okay? This is high, we don't check it out. But this one minimum, we don't know, right? This one up here, we don't know. If this is the point, that is the lowest one. If this is lower than this one, this is the minimum, okay? Absolute minimum. So we have to check, okay? Pi over 4 one more times. F over 5, pi over 4, okay? So e to the x, f of x is there, okay? I'm going to do this here. E to the x cosine x, okay? So e to the x is what? 5 pi over 4. Minus cosine 5 pi over 4. What is this one? 5 pi over 4. Understand? 5 pi over 4 is over here, right? That is a negative number, okay? That is a 5 pi over 4, okay? Reference angle. This is root 2. This is what? Negative 1. This is negative 1, okay? Cosine is what? Negative 1 over that 2, okay? So e to the 5 pi over 4 times negative 1 over square root 2. This one equals to how much? Negative 1 over red 2 times e to the what? 5 pi over 4. But this is a much greater than 1, okay?
Yeah.
Because we cannot use a calculator. How much greater we don't know. But this one a little hard. That is not good questions, I think. Okay? Because without using calculator, this is what? Greater 1 or less than, because we have a denominator is what? Negative. I'm sorry. This is a negative number, right? They're all negative are down over here. Okay, then we don't need a calculator. Negative number is down. This is the maximum down over here, okay?
Yeah.
Okay, this is down. So this point is negative number. Actually, we don't need a calculator, okay? The absolute minimum is what is that? Negative e to the what? 5 pi over 4 over square root 2, okay? That is the absolute minimum. This one is a little, okay, a lot of work. Is it okay? Let me check this, okay? Yes, it's a negative, right? That's right. That is the absolute minimum, okay? So we just need to understand, right, the interval, okay? Not pi over 2, up to 2 pi over 2, okay? You're gonna find. So we have two intersections up there, okay? Here and here, they are equal. This one is hard, okay? So I think you just try number A and B only, okay? A and B only. But anyway, we continue to work, okay? D is here. G's differentiable functions. So g is pi over 2 equals 0. That is initial, right? When x is pi over 2, y equals to 0.
Yeah.
The graph of g prime, the derivative of g is shown below there, okay? The graph of this one. Here and here, okay? Find the value of this one limit. Limit x close to pi over 2 and f of x and g of x. Put this number 2 there, what is that? F over pi over 2 and g over pi over 2. Right?
Yeah.
But g over pi over 2 is 0, that is undefined. But f over 0 is how much? Put this number f over 0. Cosine 0, that is undefined, right? Oh, no. Cosine pi over 2 also 0, isn't it? Put this number, and this is what? E to the pi over 2 and cosine pi over 2 over g prime pi over 2, they said 0 here. This is also 0, right? That is 0 over 0. That's why we have to use L'Hopital's rule, okay? Is it okay?
Yeah.
So this one is z equals to y. X close to pi over 2, we take L'Hopital's. F prime x over g prime x. G prime x, so put this number there now. Still 0 and 0, we check it out. If not, that's the answer, okay? F prime pi over 2 and over g prime pi over 2.
Yeah.
Where is g prime pi over 2 over here? This is g prime pi over 2. This is g prime, okay? The height is what? G prime pi over 2. How much? 2, isn't it? So this one equals 2. F prime pi over 2. Okay, we just have this one. F prime pi over 2. F prime x, what is that? We just did, okay? E to the x cosine x minus e to the x sine x. So from here, f prime pi over 2 there, okay? Put this not pi over 2. E to the pi over 2 cosine pi over 2. That is 0, right? That's always 0. E to the pi over 2 and the sine pi over 2. Sine pi over 2 is 1. That equals to negative e to the pi over 2. Okay? F prime, that's what is negative e to the pi over 2. That is the limit value. It's a lot of work, right?
Yeah.
Okay, that's the answer, okay? By this time, you try only A and B. Not C and D. You don't have to C and D, I think. A lot of work, okay? But to get the right highest of 0.5, okay, we don't have to solve all of the questions, okay? Only 80%, only 80%, okay? If you get the more than 80%, you get the 5 anyway. 70%, 85, I don't remember, okay? Actually, C and D is a lot of work, okay? All right. But on these questions, I recommend to only try 2, okay? A and B, okay?
Yeah.
If you have enough time, try, okay, the rest of them, okay? All right. So I mean, okay, you don't have to, okay, the rest of that, okay? I didn't mean that. If you have enough time, try the next 2, okay? If you don't have time, okay, we just try A and B, okay? Number 6, slope field. So differential equation over here, dy dx equals 1/3 x times y minus 2 square, okay? A slope field for the given differential equation is shown up below. Sketch the solution curve that passes through what? 0, 2. Initial condition is given, right? Sketch the solution curve that passes through 1, 0, okay?
Yeah.
Choose 0 and 2. Where is 0 and 2 over here? 0 and 2 over here. This point, okay, up here, right? That is all what? Slope is 0. It's okay?
Mm.
And we're going to pass through the 1, 0 down over here. 1, 0. 1, 0 over here. Slope is this one. Is okay?
Yeah.
Okay, the line must right pass through 0, 2 and what? 1, 0, okay? So how to graph this one?
Mm.
Okay, slope is 0, that is 0, 0. Okay, they are 0. X, y equal 2, they are all 0. X equal 0, always 0, okay? So when you pass through over here, okay, we're gonna make this one all the way down. But we're gonna pass through this one. This one a little weird. This one is a little weird. Pass through this point. Maybe this way. Okay. Okay, Ivo, we have a 5 minute break.
Okay.
Okay?
Sounds good.
Yeah, I gotta go bathroom, okay? So just give me 5 minutes. Okay, take a break, okay? Okay, I'll see you in
Thank you.
5 minutes, okay?
Okay, thank you.
Okay, I'm here.
Okay.
This is very weird. How can you find through the point 0 and 2? Impossible. That is impossible. To find this 0, only 1 point, okay? Only one line, because this is already different. We cannot go, okay, over here, right? To throw the point over here. Maybe one line or possible. This is one line, right?
Yeah.
So y equals 2, right? That's possible. But you cannot pass through the all together 2 there.
Yeah.
Let me check. Sketch the solution curve that pass through this one, and different one, not together, okay? Yeah, together pass through this two, that's impossible, right? Because we start over here, okay? You gotta go the right hand side. Now we can go this way, okay? This is impossible. I misunderstood the questions. Through the what? 0.2 is only one line, right? That's fine. All of this what slope of the line is what 0. It's okay.
Yeah.
The other one is pass through the 1 point over here. Now from here it's okay. Slope is, can you see the mouse over here? Slope is move over here, right? Up to the 0, okay? So move, we follow the slope, move up to the 0. It's okay?
Yeah.
Okay. To the right hand side, going to follow the line over, slope over, okay? Slope of the line over. We're gonna slope of this one, 0 again, move up here, right? So this one 0 again, over here. This slope over here. Now the 0 again and the move up here, right? That's right. Yeah, we followed it. Okay, can you see the mouse over here? We follow 0 over here, right? Close to 0. From here down, or change the slope over here 0 again, and going up, all to the 0, right?
Yeah.
So this graph is when x equal to infinite, their limit value is 2, right? Very approach right value of y equal to 2, okay? Okay, this is fine. This is a 2 graph, okay? 1 and 2. We misunderstood, right? Okay. Separate questions. If you initial value over here, down over here, if you initial value down over here, from here, can you see the mouse over, right? This is the graph looks like follow the graph. This way, okay? Follow the graph. This is the solution, okay? Maybe the other side is we continue over here, also the other side over here. Looks okay? That's right? Okay. Right. Y equal f of x is a particular solution. Particular solution is what? The initial is given. We choose, okay, this one, only this one. Okay? There's just some value here, right? So f1 equals 1, okay? F of 1 equals 1. Write an equation, the line tangent f of x equals 1, okay? So we're going to find out particular solutions.
Okay.
Particular solutions given by okay, this is given. No, we're gonna find the not solution, right? Get right the equation of line of tangent, okay? F of x. So particular solution is what? The 1 and 0, okay? But there's can you find the line of tangent at x equal 1 there? At x equal 1 there. What is the x equal 1? They set the point over here, okay? When f of x is 1, y is 1. That is the point when x is 1, y equals 0, okay? So we're going to find the equation of tangent at this point, 1 and 0. It's okay? Can you see that word 1 and 0? 1 and 0. This is slope is this one, okay? This is slope. 1 and 0, yeah, slope of this one, okay? We got the point over here. And find the slope. How can you find the slope? dy dx, that's the slope, okay? dy dx, that's a slope, isn't it? That is what? Negative 1/3 x times y minus 2. Okay, this slope can be obtained what? When x equals 1, y equals 0, okay? So 1/2, x is 1, y equals 0, minus 2 is negative 2. Slope is what? Negative 2/3. It's okay?
Yeah.
The differential equation is when you put in any number of x and y, that gives right the slope of tangent at this point. For example, if we choose over this point, I'm going to choose this one, 1 and 1, okay? X is 1, y is 1. Slope is over here, a little close to positive 1/2, right? So when x is 1, put this number, okay, at this point, x is 1, y is 1. dy dx, how much? Put this number, x is 1 there. 1/3, x is 1, y is 1, negative 1 square, right? 1 minus 2 is a negative 1 square equals to 1/3. That's correct, right? This is very close to 1/3, isn't it? 1 and 1 over there, okay? 1 and over here. The graph is what looks like this way. Slope, okay?
Yeah.
This looks like 1/3, okay? Now, the equation of line tangent. The equation of line tangent is slope is 2/3. So y minus y1. y1 is 0, okay? Y minus 0 equals negative 2/3 x minus 1, okay? You can leave it this way too. It's okay. This is okay, right?
Yeah.
When x is 1, y is 0. It's okay. Let me see. dy dx. Let me check more times. 1/3 x equal 1. Y equal 0. Now y equal 1. Oh, y equal 0. There's a y equal 1 there, okay?
Yeah.
Oh, that's correct. X equal 1, y equal 0. X equal 1, y equal 0. Oh, 2 square. I'm sorry. That 2 square, okay? That depression 2 square. Boy. That's why you got one negative sign, okay? That is actually what generally what that is a positive, right? That's why I thought it's weird. That's a positive slope. So 1 over here, 1/3 times 1, negative 2, y equals 0 over there, negative 2 square, okay? 4/3, that should be positive slope, okay? That's why I thought it's weird. That's the answer, okay? So we don't need the 0, just right, y equals 4/3, x minus 1. You can leave it this way, okay? You don't have to expand this one. Using this one, we're gonna find out what the approximation f of when x equals 0.7, okay? 0.7 very close by x equals 1, okay? So you can use this one for the approximation, okay? So f of what 0.7. You put this number at 0.7 there. 0.7 minus 1, okay? 4/3 times negative 0.3, isn't it?
Yeah.
That is a negative 0.4, okay? That's nice. That's approximation, okay? Now find the particular solution y equal f of x for the given differential equation. Initial condition is 1, 0, okay? Now we're gonna find the exact, another one, particular solution of this differential, okay? The initial condition is given by same this. At the same point, when x equals 1, y equals 0. So at this point, 1, 0, okay? So we have to solve this differential equation now, okay? Anyway, we need to solve this one. dy dx equals to 1/3 of x and y minus 2 squared, okay? This differential equation is separable, okay? Always try to use a separable, okay? X is the x, y to the x. So times dx is what it is, this way, dx. But x is okay, but this one is has variable y. Move to the left, right? Divide y minus 2 square, okay? So 1 over y minus 2 square dy equals what? Still right inside, they are all as x, okay? These three move to the left, but keep the right hand side, that is better. After that, we take integral, okay?
Yeah.
1 over y2 square is how much? That is equals to y minus 2 minus 2, right? And dy equals 1/3 x dx. Minus 2 is plus 1 is negative 1, okay? So minus 2, negative 1 there, and divided by negative and negative. It's okay?
Yeah.
That is antiderivative, right? It's same thing. Okay, that's antiderivative of plus 1 is negative y, and divided by negative 1. But this constant is nothing, okay? Same as this one. That is antiderivative. This antiderivative you can use 1 over y minus 2, right? That is equals to, what is the antiderivative one? 1/3 times square over here, okay? This was the antiderivative by x squared over divided by 2, right? We still have a 1/3 there, 1 over 6 x squared, isn't it? And the plus c, right?
Yeah.
Okay. Now using this one, we can find, okay, the value of c, because we already gave, right, this initial here, okay? When x is 1, y is 0, okay? Put this number in there. When it says y equals 0, what is y equals 0? 1 minus 0 minus 2. That is what? 1/2, right?
Yeah.
1/2 equals to x equals 1 there, 1 over 6 and plus c. So c equals how much? 1 over 2 minus 1 over 6. 3 over 6 minus 1 over 6 is 2 over 6, which is equals to 1 over 3, right? So c equals actually 1 over 3. Now anyway, we're gonna express y equals f of x. They want to express over here, right? Y equals f of x. So this is, put this number c there, okay? Minus 1 over y minus 2 equals 1 over 6x. This is 6x squared over 6 plus c equals 1/3. But we're gonna express y over here, okay? That's reciprocal, right? So we need a little just change. This one is use the same common denominator, x squared plus what is that? Times 2 times 2, right? 2. It's okay?
Yeah.
Now change one more step by this negative move to the left. 1 over y minus 2 equals what? Negative x squared plus 2 over 6. After that, we take reciprocal, right? Because y minus 2 move up, 1 is going down, 6 is going up, this is going down. It's reciprocal. So y minus 2 is equals how much? Negative 6 over, flip the number, okay? Are you agree with this?
Yeah.
After that, you can add 2 both sides. So finally, we got this one. Y equals minus 6 over x squared plus 2 and plus 2, okay?
Okay.
That is a particular solution of the differential equations. Are you okay with this?
Yeah.
So we just did up to number 6. Okay, all right. Okay, we can try some calculator section over here, okay?
Okay.
It's a 2018 number 1, okay? Only calculate sections. Just to try one question today, okay? Number 1. This is we use calculator, okay? Okay, people enter a line for escalator at the rate of modeled by the function r is given by. This is the rate, okay? Function of r, okay?
Yeah.
At the rate modeled. This is rate rt. Rate is a kind of derivative, right? The slope, okay? Instant slope. instant times, they entered 44 t over 100 cube and 1 minus t over 307 for this time, 0 to 300. After that, t is what? Greater than 300. Rate is what? 0. What that means? Slope is 0 is what is it? Constant. It's okay? It's a constant number. It doesn't change. Between 0 and 3, that increase. It's okay? After that is what? Slope close to 0. It's okay? Alright, that is a constant. Okay? That's the meaning. Not 0 people, okay? Okay.
Yeah.
You understand this one, okay? This is the rate. They said this is rate. Rate is what? People's number of people per time, okay? Per time t. That's the rate. The time is a minute, a second, okay? Seconds. Okay, that's the rate. All right, where t is measured by people per second. Okay, we did already, and t measured in seconds. As people get on the escalator, they exit the line at constant. Okay, outside. Okay, escalator over here. Out is 0.7. Okay, 0.7 every seconds. Okay, so there are 20 people in line at time t equals 0 over here. There are 20 people. They are waiting. Oh, there are 20 people in the escalator, right?
Yeah.
RT is measured people measured in seconds get on as the people get on elevator. Okay, over here, right? 20 people in escalator, okay? So 20 people there. Escalator. At t equals 0, okay? At the beginning, 20 people, okay, they are right on the escalator, okay? That's it. How many people enter the line for the escalator? That is what? Enter the line, okay? That is enter the line. 20 people on this one. This enter the line is coming from here, okay? How many people enter the line for the escalator during time is t and 300, okay? So all together, isn't it? The people number is RT. That's all number of t, okay? This is what you can use 300, okay? 300.
Yeah.
Get in the line, okay? How many people between 0 to 30? 0 and 300. You take all that integration, okay? T over 100 cube times 1 minus t over 300, that is 7 to dt, right? Okay, when you take right all sum of this derivative, that is what? Between 0 and 300, okay? How many total number of people getting in the line? It's okay?
Yeah.
So we're gonna use, okay, our calculator. Oh, this one is, okay. Anyway, we're gonna use calculator. Here. This one is a little work, okay? Here you go, integral, okay? All sum of numbers between 0 and 300, okay? 300 seconds is how much? Okay, 1 minute is 55 minutes, right? Yeah, it's from 0 to 300 seconds. So I'm gonna put this number 44, the integrand here, 44, and t over 300, no, not 100, t over 100, and cube. The next one is 1 minus t over, at this time, 300. And 300 out over here, cube 7. Wow, a lot complicated. Okay, 7. So we're gonna take a dt, okay? Take dt all together. How much? 270, right? I don't know if that's the exact number, but anyway, it's gonna be 270 there, okay? Are you okay with this? 270, right? So this one equals to 270. First one, 300 seconds, which is 5 minutes. When you divide it by 60, right, it's gonna be 5 minutes. First 5 minutes, or some of this one is what? 270 people, okay, they work in the escalator, okay? Right, the next one over here. During the time 0 to 300, there are always people in line for escalator, okay? Yeah. How many people are in line at t equals 300? Where is it? There are always people in line for the escalator, okay? How many people in line at time t equals exactly 300? How do you think?
Yeah.
There are already t equals 0, there are 20 over here, right? It's okay? At time t, at the starting, there were already what, 20 people in the line, okay? Yes, okay. Now we're gonna find, okay, how many people are still in the line, okay? This is a little hard to understand, but you can try, okay? Number B. Because we check it out, okay, every time is 0.7 people per out. It's okay?
Yeah.
Right? Yeah. So we have a 20 over there. How many coming in there? How many coming in? From 300 over here, okay? RT, it's okay? 44 times T over 100. Same as this, okay? Cube minus 1 over T over 300, 7 dt, right? That is coming in there. From here, we already 20 over here. Coming in over here, this one, how much? 270, right? But every time is 300 seconds, right? 0.7 is out. 0.7 per second is out. 300 times 300 is how much? 210 people going out. Are you okay with this?
Yeah.
This one a little hard, but you can figure out, okay? So how much this one? 270 is going in, so 290, right? 20 plus 270 going up there. But 210 during the 3 seconds, right? 210 people is what? Leave the escalator, okay? So 290 minus 210 is what? Still 80 people in the line. Are you okay with this?
Yeah.
Okay, that's the answer, right? Oh, this is a little hard to understand, but just to figure out kind of physics, okay? The number C there. If t is greater than 300, what is the first time t there are no people in line for the escalator, okay? T is 300. Up to 300, still we have 80 people there. Is it okay? For the first time t, there are no people in the line. Okay, just before over there, what is there? After t300, 0. 0 people coming in there. Is it okay?
Yeah.
0 people coming in there. So we still have 80 people. It's okay. We still have 80 people. T equals 300. Choice B over here. We still have 80 people on the escalator. Okay, no more people coming in. Okay.
Yeah.
But we know that no more people came in. So only 80 people because what the door is closed. But this 80 people is what they leave every second is what 0.7 people, okay? To leave every 80 people, okay, we can divide by 0.7 people, okay? So 800 over 0.7 over here. Without this one, we can use a calculator, okay? We don't need this one.
Yeah.
Yeah, just what 80 divided by 0.7 people. It takes the time over here, right? 114 seconds. Or what time of t? Okay, we can use, okay, they didn't say anything nearest the second. Okay, then we have to use about 3 decimal, okay? 286. 114, 286. Okay, it takes what? All this 80 people to live is 114, 286 seconds. But that is not the answer, right?
Yes.
Okay, we start right from 0. Okay, this one is after 300. It takes what to live all these 80 people. It takes 140 minutes to 286 seconds. Okay, so we can add it over here, right? Up to 7. 300 additional over here 114.286. Okay, so the real is I'm gonna use this. For after this is 114.286. We tell t equal there. We're gonna find all this time they're asking you. Okay, so 300 plus 114.286. That is 414.286 seconds. Okay. So no one in the one escalator. Is it okay?
Yeah.
All right. Just choice D. Okay. All right. Number D there. T is between 0 and 300. At what time T the number of people line in minimum? Okay. The minimum letter, minimum, okay? To the nearest whole number, find the number of people in the line at this time, okay? So maybe the minimum up here, the total number of in the line, okay? Wow, this is a lot of work, okay?
Yeah.
Let's find total number of in the line, same as before, okay? We did this one, go back over here. Just before we have this one, okay? 20 plus from 0 to 300. I'm going to use the 14 RT, okay? RT is this one. And the minus, this is out every time, okay? 0.7T is out. It's okay?
Yeah.
So this is not 300, okay? And sometimes T, we replace this is a times T. That's a little hard, okay? Sometimes T. Are you okay with this?
Yeah.
And that is what the number of people, when this was number of people in times T, right? In escalator, okay? 20 plus 0 times this T, right? T, R, T, and minus DT, and minus 0.0 T, okay? All right, now let's find the minimum value, okay? So absolute minimum, okay? We need always what? First derivative. Is okay? First derivative. So take a derivative with respect to time. But this is to avoid the competition, we can use K, okay? Different letter, okay? RK. So P prime with respect to time P prime. P prime T equals how much? 20 plus, this is out. This is second fundamental of calculus, okay? When take a derivative with respect to T going into the inside of it, that is RT again, right? And the plus take a derivative is 0.7, okay? You have to solve this one to make a 0 here, okay? RT is now 0.4444 T over 100 cube 1 minus T over 300 7 equal minus 0.7, that equals 0.7. So we're gonna find the time T which make equals 0.7. That is very hard. We have to solve this one, okay?
Yeah.
Use a calculator. We have to find the intersection over here, okay? Can you see that right calculator over here, right?
Yeah.
I'm gonna make a graph over here. We're gonna find the intersection right the part. So y equals this is a y1, this is a y2, okay? So y1 equals 44, that is y1 equals 44. We did already up here, okay? I'm going to just copy. That's the graph. It's okay? But this is a times t, right? That's why I get this one. No, well, we're going to make this one. Okay? No. Not the integral. This we don't need the integral. Just the y equals 44 times t, this one. The graph of this one.
Okay.
Up to here. That's the graph. Where is the graph? Wow, graph is here. 300, right? That's why it looks like big. It's okay? Take it over here, right? Okay, 300, okay? Okay, y direction is 2. I'm gonna make a y direction over here. $100 is better. Negative 52, positive 50. That is better. Okay? But still, this is okay. After that, we're gonna make another y equals 0.7, right? Okay, we have 2 points over here. Here and here. That's the p prime, okay? To find this one. But this times RT minus 0.7 at this point is what? 0.7 is above this one, okay? That is negative. Are you okay with this?
Yeah.
I'm gonna make a graph of this one, okay? The graph looks like this one. At 0.7, P prime is negative. Not 0.7. This point of 30.013, okay? 33.013, okay? At x equals 33.017. This is a minus, this is a plus. This is a little hard, okay? 3.013. After that, over here, this is RT is greater than 0.7. That is a positive over here, up to where? 166.5.575, okay? This is 166.5.7573. Okay. All the minus. But at this point, the decreasing and increasing, right? This is the increasing, decreasing. So we're gonna find the minimum value, okay? This one we don't need it. This is the relative maximum, okay? We check right the line minimum, okay? This is the minimum value, okay? So we're gonna find what this number at x equals 33. What is the value of y, okay?
Yeah.
Okay, this one is a lot of work. Okay, now let's find anyway. At time 33, this is minimum is okay. 33. Okay, put this number 33013. Okay, where? Where is the people over here? This is number of people. Okay, are you okay with this?
Yeah.
Can you see the equation over here? We're gonna put this number here. Okay, a lot of work. So t equals 33 1.3. Okay. So I'm going to do this one. 20 plus.
Yeah.
This is 33.013. After that, subtract. Okay, minus. This is subtract over here, okay? 0.33, okay? 0.0 t equal 33.3, okay? So minus 0.7 minus 0.7 times 33.1013, okay?
Yeah.
How much? 3.8. Is okay?
Yeah.
3.8. So at this point is 33 point over here, that is 3.8. So we gotta check out at the beginning of here, okay? At the end, what is it? Between 0 and 3, okay, 0 and 300, we have over here 3.133, that is what? Only 3.8 or 3 people, right? That's the minimum. 0 is what? 20 over here, isn't it?
Yeah.
So going down. And over here is 166 going up here, right? Increase, decrease, right? Maximum. After that, going down. After 300, what happens? At this way, 300, what happens? 300, there are 80 people left over here, right? 80. It's okay? That is 80. But this is the lowest point, okay? 3.803. Okay? So find the number of member in line. This time minimum line is absolute minimum is what is the absolute minimum? 3.803 people at time t equals what? 33.103. Okay, that's the answer. Are you okay with this?
Yeah.
This is very hard. Okay, a lot of work. This one, number one, I think. Okay, yeah, number one is a little more work. Anyway, okay, just try to get used to this type of questions using take a derivative. Okay, we need the integrations. Sometimes they asking you find the minimum and maximum. Or they gave this one. If you got a little more practice on this type of questions, okay, there will be no problem at all. Okay, so try this number one by yourself one more times. Okay.
Yeah.
Okay, I'm gonna send out the link, all right, in your the email. Okay. Okay, I'm
Yeah.
gonna stop the link.